Hello, today in this video we are going to see how we can create the APIs using which we can perform the image analysis all using Spring AI. So we are going to build a very simple application wherein the user can provide us the one or more images. Also user will specify the query related to the analysis that they want to perform. Based on the information which is provided by the user, our LLM will process the information and accordingly provide the useful insights. So before we jump into the coding part, let's understand how this works. So the concept behind this is the multimodality, or we can say this kind of use cases can be solved with the help of multimodal LLMs. So when we say multimodal LLMs, these are nothing but the LLMs that are capable of processing information from various sources all at once. So you can provide the information such as text, images and videos all at the same time. Our LLMs will process that information and accordingly provide the response. So when it comes to our application, this is how the overall flow will look like. User will provide the text query or the kind of analysis that they want to perform. User will also provide the one or more images, and these images can come from various sources. For example, these images can be the set of images that are already present inside our application, or user will upload the specific image and ask the queries, or these images can come from the URLs that are already available on internet, or user can also provide the image information in base64 encoded format. So the images can come from various sources. So once we have the user query and the set of images, we will build the user prompt containing both these information. We will give this to the Spring AI chat client. Chat client will forward this information to multimodal LLM, which in our case is going to be Google Gemini 2.0 Flash. And based on the information which LLM has received, it will process the information and accordingly provide the response, or we can say insight, based on the query which is asked by the user. So one simple example is, let's say user has provided two images and user is asking count the number of people in these images. So the AI will respond like the number of people that are present in both the images, and accordingly it will send the response. Now let's understand how we can create this kind of application using Spring AI. So the main logic, or we can say the core implementation part, can be divided into the three main steps. First one is the image that is provided by the user. We need to convert that image into the Spring AI media object. So irrespective of the source from where the image is coming, first we need to convert it into the Spring AI media object. Then we need to combine this media object and the query which is asked by the user. We will pass it to the LLM and simply extract the response. So this is how the overall main logic will look like. So first, based on the image or media that is provided by the user, we need to create the media object. Now this image can come from various sources. As I mentioned earlier, it can be present inside the application. It can come from the external URLs, or it can be the image which is uploaded by the user, or user can also provide the image data in the base64 encoded format. So first we need to create the media object, then we need to combine this media object as well as the query which is asked by the user, and simply call the LLM using Spring AI chat client, and once we have the response, we will simply extract it. So this is the main logic using which we can implement the image analysis APIs. Now let's come to the project structure, how the overall project structure will look like. So our application will be Spring Boot based application. So the name of the application is Spring AI Image Analysis Cookbook application. It will consist of the one controller wherein we will expose four kind of endpoints to see all the use cases. Like we will see the use case related to the images that are already present inside our application. We will see the use case wherein user will upload the images. Third use case will be user will specify the image URLs that are already available on internet. and fourth will be related to the input, wherein user will provide the image data in base 64 encoded format. Then we have the service layer, which will actually interact with the LLM and send the response back to controller. And for the entire application, we will be using the 4 DTOs. And in order to send any error information to the user, here we have created one exception class. Then we will be having one Spring Boot main application class. And then we have the application.yml and pom.xml containing the configuration related to LLM, and it will contain the project configuration. And at last, we have created, or we have placed 2 sample images within the application to see the use case related to the Classpath scenario that I mentioned earlier. So now let's jump to the IntelliJ. So here you will see the project structure is exactly similar to the one that we have discussed now. Let's start with the pom.xml. Inside pom.xml, you will see we are making use of Java version 21, and the Spring AI version is 1.0.0, which is the stable version. For creating the REST APIs, we have added Spring Boot starter web dependency. For interacting with the LLM, we have added Spring AI starter model OpenAI. So behind the scenes, we will interact with the Google Gemini APIs. And then we have added one dependency for logging, which is logbook Spring Boot starter. This is just for the logging purpose. So if we want to see what kind of information our application is sending to the Google Gemini or any LLM, we can see this with the help of logbook, which will simply log the entire information in the application logs. And then we have the Spring AI bomb dependency, which is useful for managing the dependencies related to Spring AI. Coming to the application YML, at the very start, we have just configured our application name. Then we have specified the configuration related to AI. So here you will see, since we are interacting with Google Gemini, we will pass the Gemini API key. This will come from the environment variables. And since we are interacting with Google Gemini, we have configured the base path here, and we have configured the path suffix. Then we have specified the model which we are going to use. In our case, it is Google Gemini 2.0 Flash Experimental. And for processing images, we have specified the base URL and image path of Google Gemini only. And then also we have specified the model, which is Gemini 2.0 Flash Experimental. Now, if you are working with OpenAI, then you can simply skip these configuration here, since we are interacting with Google Gemini, because of which we are overriding the default URLs that are configured by Spring AI. Now, since we added the logbook dependency for logging the LLM calls, we have set the logging label to trace for logbook. Now coming to the main class, for here you will see it contains just one additional bean, which is useful for enabling the logging via logbook, for which we are creating the REST client customizer bean. And here you will see we are adding the interceptor for logbook client HTTP request interceptor, which will intercept all the requests that are made by the Spring AI chat client, and accordingly it will print the request and response. Now let's jump to the image analysis controller. So inside this controller, we have created 4 separate endpoints for showcasing 4 separate scenarios. So the base path for our controller is API v1 image analysis, and the kind of scenarios that we are supporting are: the user can provide the file name which is already available inside our application, and our application will process it. This is the first scenario. Second scenario will be user can upload the images from their system, and accordingly our application will process. Third scenario will be user can provide the image URLs that are already available on the internet. Fourth will be scenario wherein user can provide the image data in base 64 encoded string. So before covering each and every endpoint in very detail, I will explain you the core logic, and accordingly we will see each and every endpoint in action. So User will send the request which will come to this controller. Controller will forward to the different methods that are available inside the service class. Service class will interact with the LLM and accordingly provide the response which will be sent back to the user. So the core part will remain the same. Now coming to the service class, I will explain you the main logic, then we will cover each and every endpoint in very detail. So coming to the service class, here you will see at the very top we have defined the system prompt. Since we are building the image analysis API, we are telling that you are the AI assistant that specializes in image analysis. Based on the prompt and the images that are provided by the user, try to resolve the queries. If user is providing any query which is not related to the image analysis, you can simply send back the error response saying I can only analyze images and answer related question. So we have defined the system prompt. Then we have defined the error response. As we have seen in the system prompt, if there is any error, the AI will simply respond with this particular message. Then we have the chat client. Chat client is useful for interacting with the LLMs. So here you will see we are initializing the chat client inside the constructor with the help of chat client builder, which is also provided by the Spring. So here you will see we are calling chat client builder.build, which will simply initialize the chat client and which we can use for interacting with the LLMs. Now let's first understand the core logic, how the image analysis will be performed, and then we will cover each and every endpoint in very detail. So here we have created one central method. So irrespective from wherever we have received the image, all calls will come to this particular method, which will actually call the LLMs and LLM will perform the analysis. So here you will see as an input we are receiving the user prompt and we can receive one or more images in the form of media list. So here we have added certain basic checks. If there is any error, we are throwing the custom exception saying no valid images were provided. And then using the chat client that we initialized, here we have specified the system prompt that we have just seen earlier. Then we are creating the user prompt wherein we will pass the query which is provided by the user. Here you will see inside the text we are passing the prompt, which is nothing but the query provided by user. And then we are specifying the media. This is nothing but, in our case, it can be one or more images. So inside, while creating the user prompt, we are specifying two kind of information, text as well as images. Then we are calling the LLM, and once we have received the response from LLM, we are extracting the main content or the reply that is sent by the LLM. Now if reply is the error response, let's say user is asking any invalid question which is not related to the image analysis, if the response is the error response, which is nothing but the response which is sent by LLM, I can only analyze image and answer related questions. So we are throwing the custom error message saying the provided prompt is not related to the image analysis. This is nothing but the guardrail that we have kept to prevent the abuse of our endpoints. So if the response is valid, we are simply sending the response in the form of this particular record, image analysis response, wherein we have one field named as response. Inside that response, we will simply keep the response that we receive from the LLM and send back to the controller. So this is the main logic, or we can say the core logic using which the image analysis will be performed. Now coming back to the controller, wherein we will try to understand each and every endpoint in detail. Now here the focus will be how user can provide the images in various formats. So the first use case is user can specify the file name for the images that are already available inside our application, for which we have the endpoint analyze from class path. The path suffix is from class path. As an input, we will accept the two fields from the user, which is the prompt and the file name. Prompt is nothing but the query, image analysis query specified by the user, and file name is nothing but the images that are already available inside our application. Here you will see we have kept two images just for the demo purposes. So based on the information which is provided by the user, it will be forwarded to the service class. Service class will respond in this particular DTO, image analysis response, and we will simply send back the response to the user. Now coming to the analyze image from Classpath method, at the very beginning we have kept certain basic checks which checks that the prompt cannot be empty, for which we have created the common method. Next check is related to the file name cannot be empty. Now if these two information are valid, then we will create the media, we will forward it to our central method, and LLMs can perform the required operation. So how we can create the media? Since in our case the images are already present inside the class path, here we are making use of the class path resource, which will look for the images that are present inside this particular folder, which is nothing but the image folder. Now if file name is found, then we are good. If file does not exist, we are simply throwing an error. Now let's say the file was found. Based on this, we have to create the media object, for which we have the constructor new media. We will specify the file type, in our case it is JPEG, and we will specify the image resource that we have created. So when you see the media, it accepts two kind of information. First one is the MIME type, which is nothing but the media type, in our case it is JPEG, and another one is the resource. So this is the main thing that we want to understand. Based on the information that we are receiving, we have to create the resource that we can pass to the media object. Now once we have the media object, we will send this information to the central method that we have just seen now, which is perform analysis, containing the prompt and the list of images. In our case it will be 1, and simply the LLM call will be done, and accordingly we will receive the response. So this was the first method, wherein the images were already present in the class path and user was just specifying the prompt and the file name. Coming to the second part, which is analyzing the images that are provided by the user. So for this particular endpoint, user can upload the images that are available on their system, and our application will process them accordingly. So here as an input, you will see we are receiving the images. It can be one or more. Also we are accepting prompt. So these will be forwarded to the analyze images from multipart method, which is present inside the service class. The overall core logic will remain the same. First we will validate the prompt, then we will validate that the file name, the files that are uploaded by user cannot be empty or null. Then we need to convert the provided files into the media object, for which we have created the stream, and the basic operation that this stream will perform, it will convert each and every input file into the media object, for which we have created convert multipart file to media. So if we see this method, here you will see as an input we are receiving the multipart file. We are extracting the content type. Based on the content type, we are determining the MIME type, which is nothing but the media type. For this, here we have created the method determine MIME type. So based on the content type that was received, it will check what kind of image it is. So once we have the MIME type, we have the file. Now we need to create the media object. So here you will see we are creating the new media object, specifying the MIME type. And when it comes to multipart, we can directly get the resource using .getResource method. So we will go back to our stream. So once we have the list of media files, we will simply call our centralized method, which is perform analysis. Next we have the from URLs, wherein user will specify the image URLs that are already available on internet. So here you will see the input request is URL analysis request. As an input, we will receive the list of image URLs, and also we will receive the prompt. So once we have received the input, it will be forwarded to this method analyze image from URLs. So here you will see we have received the list of URLs as well as prompt. We will perform the basic validation. Now before we can send this information to the user, we need to convert these URLs into the media object. So similar logic that we have seen earlier, we are making use of stream, and then we will convert each URL to the media object. Now let's understand this method. Here you will see as an input we are receiving the URL. Now we need two kind of information, what kind of media it is and how we can download it. So for determining the MIME type or media type, here we are making the pre-flight request using URL and URL connection. Once we have the MIME type, now we need to download the image which we can provide it to the LLM. So in order to download the image, here we are making use of the URL resource which will accept the image URL as an input, and it will simply create the resource, which is nothing but it is a lazy load kind of object. So the actual image will be downloaded when the chat client will make a call to the LLM. Now we have the resource, we have the MIME type, we can simply create the media object. Here you will see we have specified the image resource, and based on the MIME type that we identified from pre-flight request, we are creating the MIME type object here. Once our URLs are converted to the media object, we will simply pass the information to the centralized method. So this was regarding the third endpoint. Now coming to the fourth and final endpoint, wherein user can specify the information in the form of base64 encoded string, for which we have created the Java record, which is base64 image analysis request. It will accept the user prompt and it will accept the list of images, and here you will see inside the list is of type base64 image, wherein they can specify the media type and the base64 encoded string containing the image data. Now once we have the request, we will forward it to the service class method analyze image from base64. Again we will perform certain basic checks, and for each image we will call this method, that is we need to convert the base64 data into the media object. So coming to this method, here you will see once we have the base64 encoded data, we will simply decode it, and from this particular information we are creating the byte array resource, and also we are creating the MIME type object, for which all we have to do is based on the base64 image object we need to call this MIME type method or get MIME type method, and using this we are simply creating the media object. Now once we have the list of media, again the logic will remain the same. We will call our central method which will simply send the required data to LLM, which will process it, and we will receive the response. So these were the 4 endpoints. Now let's see all these endpoints in action, for which I have already started our application. First we will call our first endpoint, which is analyze image from Classpath. Here you will see user is specifying the name of the image which is already present on Classpath. Here you will see we have two images, Spring AI chat client matrix and Spring AI observability, and user is specifying the query or analysis that they want to perform. In this case it is asking the LLM what do you understand from this image. So when user will submit the request, LLM will process this information and simply send back the response. So let's see first what exactly this image contains. So here you will see this image contains the data related to the Spring AI observability. It contains information related to chat client metrics and prompt logging. Let's compare this with the response sent by LLM. So here you will see the LLM is saying this is an advertisement for Spring AI observability, and it contains the insights related to the chat metrics and prompt logging. So this was the first endpoint. Coming to the second endpoint, wherein user can upload the images from their system, for which we need to call this endpoint v1 image analysis from files endpoint, wherein user can specify their query, and also user can upload the images from their system, for which inside the body we need to click on form data type, and then we need to specify the field name which is images, and simply we have selected two files from our system, and based on this user is asking is there any similarity between these two images. Basically we will send the request and the AI will perform the analysis, and accordingly here we are receiving the response like yes, there are several similarities between these two images, both are related to Spring AI and so on. Now coming to the third endpoint, wherein user can specify the image URLs that are already available on internet. For this we need to call the API v1 image analysis from URLs endpoint. As an input, user will provide the prompt and the image URLs. So here user is asking the simple query, what colors are used in the provided image. So when we will send the request, our application will send it to LLM and we will receive the response. So here the response is like the image uses the following colors. Now coming to the fourth endpoint, which is API v1 image analysis from base 64, wherein user can specify the prompt. They need to specify the media type, which is image slash JPEG, and image data is provided in the base 64 encoded format. Here we have created the base 64 encoded data for one simple image and specified inside the data field. And now when we will send the request, here you will see we will receive the response. So here is the text extracted from images, like what kind of image it is. So this is how we can perform the image analysis all using Spring AI. Now coming to the logging part. Now earlier we added the logback dependency to see what kind of data our application will send it to LLM and what kind of response we will receive. For this we'll make use of this endpoint wherein the images are available on the class path. So we will again send the response and see what kind of information is getting printed here. So here you will see we are calling the Google Gemini API chat completion endpoint, and the query which is asked by user, what do you understand from this image, is mentioned here. And here you will see the Spring AI is passing the image data in this particular format, wherein we have the type object inside which we have the URL containing the data. It is of type image JPEG, and the image data is in this particular format, base 64 encoded format. So this is how the information goes to the LLM, wherein prompt as well as images are forwarded to the LLM, and response that we will receive will simply contain the response that we just seen in the Postman. So this is how we can also log the information and understand how this is working behind the scenes. Yeah, so that was all regarding Spring AI image analysis. For this we have also created the detailed article which you can go through, and also the example that we discussed is uploaded on GitHub. You can simply check out and try this example if you are interested. Yeah, so that's all from my side. I hope you found this useful. Thank you.